Alright, then let's begin. Making sentences. What we should be able to get from our little game lexicon scanner is a list that looks like this. Okay, so yeah, we go here, we import all of this. Yes, alright. This will work. This will also work on longer sentences such as lexicon scan and all of this. Okay. Now let's turn now let's turn this into something the game can work with, which would be some kind of sentence class. If you remember grade school, a sentence can be a simple structure like subject, verb, object. Obviously, it gets more complex than that, and you probably did many ways of annoying sentence diagrams for English class. What we want is to turn the preceding what we want is to turn the preceding list of tuples into a nice sentence object that has subject, verb, and object. Match and peak. To do this, we need 5 tools. A way to loop through the list of scanned words, that's easy. A way to match different types of tuples that we expect in a subject verb object setup. A way to keep at a potential tuple. A way to peek a way to peek at a potential tuple so we can make some decisions. A way to skip things we do not care about like the stop words, and a sentence object to put the results in. Okay, so we will be putting these functions in a module named .parser. Okay, exercise 48. In order to test it, we use the peek function. Okay, so I can just cd2 exercise 48. No, 48. Yeah. Okay, again. I can create a new file, parser parser.py. Right. Okay. Then we have, okay, in order to test it, we use the peek function to say look at the next element in our tuple list and then match to take one off and work with it. Okay. The sentence grammar. Before you can write the code, you need to understand how basic English sentence grammar works. In our parser, we want to produce a sentence object that has 3 attributes. A subject. This is the subject. This is the subject of any sentence, but could default to player most of the time. Since a sentence of run north is implying player run north, this will be a noun. Sentence dot verb. This is the action in the sentence. In run north, it would be run. This will be a verb. This will be a verb. Sentence object. This is another noun that refers to what the verb is done on. In a game, we separate our directions, which would also be objects. In run north, the word north would be the object. Hit bear, the word bear would be the object. A parser then has to use the functions we described. A parser then has to use the functions we described and, given a scanned sentence, convert it into a list of sentence objects to match the input. Right. A word on exceptions. You briefly learned about exceptions but not how to raise them. This code demonstrates how to do that with the parser error at the top. Notice that it uses classes to give it the type exception. Also notice that the use of raise keyword, okay. Also notice the use of the raise keyword to raise the exception. In your test, you will want to work with these exceptions, which I'll show you how to do. Okay, the parser code. If you want an extra challenge, stop right now and try to write this based on just my description. If you get stuck, you can come back and see how I did it, but trying to implement the parser yourself is good practice. Okay, I will now walk through the code so you can enter it into your exercise 48 parser.py. We start the parser with the exception we need from the need for a passing error. Okay, so parser to convert the given string into a subject, sorry, into a sentence of the form subject, verb, and object. Okay, so all nouns, right? Run north. A direction can be an object, right? A verb will always be a verb. I know that. Okay. So we go class, we define a parser error, and we inherit exception. And that's all. That's all we do, and don't do anything else. Okay. So this is how you make your own parser error exception class you can throw. Next we need the sentence object we'll create. Okay. And we don't need anything else. Then we have a sentence object. Sentence. Okay, stores subject, verb, and object parts. So we can create a sentence of type object, and then okay, so it is passed from outside. Remember, we take noun, princes, tuples, and convert them. Okay. Right. So we will be accepting tuples like and direction, then north. Alright. So we have a subject, a verb, and an object. Okay. So we define our own variable, right? Self dot subject. Self dot subject equals to, we take the second element. Verb and self dot object equals to obj, because object is a keyword. Okay. There's nothing special about this code. So far you're just making simple classes. In a description of the problem, we need a function that can peek at a list of words and return what type of word it is. Okay, if word list word equals, return word 0. Okay. Okay, so we have a peek function that determines the word. This, okay, takes a word list, and then if we have something word list, we can say word equals word list of 0, because we are determining the type, returns the type of the word. Okay, so effectively, and so word list is a tuple. Tuple, right? Then we can return word, or else we return none. Okay, we need this function because we'll have to make decision about what kind of sentence we're dealing with based on what the next word is. Okay, then we can call another function to consume that word and carry on. To consume a word, we use the match function, which confirms that the expected word is the right type, takes it off the list and returns the word. Okay, so word list and expecting. So we pop from the word list. Okay, so it is a list. Okay, word list is a list of tuples, I suppose, right? Okay, I don't really know right now, but since we are referencing the zeroth part, type, right? Return word, else, return none. Okay, yeah. Match function returns, okay, word if it matches the expected type. We take a word list, then we take what we are expecting, then if word list, we will pop the word, right? Word equals to word list dot pop. Then we check. Okay, I should. Then we check if word type equals to what we are expecting, right? Then we return word, else we return nothing. Again, this is fairly simple, but make sure you understand this code. Also, make sure you understand why I'm doing it this way. I need to peek at the words in the list to decide the kind of sentence I'm dealing with. Then I need to match those words to create my sentence. Okay. So I need to peek what kind of sentence, right? The last thing I need, the last thing I need is a way to skip words that aren't useful to the sentence. Okay. Peek. Okay, these are words labeled stop words that are words like the and okay. So we take a word list, then we match. Okay, so it will just pop and not return anything, right? Remember, the skip doesn't skip one word, it skips as many words of that type as it finds. This makes it so if someone types scream at the bear, you get scream and bear. That's a basic set of passing functions, and with that we can actually pass just about any text we want. Just about any text we want. Our parser is very simple, though so the remaining functions are short. Okay. Word list. Okay, so when we pop, we are actually return word, but we are not storing the word anywhere, right? Okay, so we call verb return match. Okay, parse verb. Then we have parse object. Skip word noun return match. Expected a noun or a direction or direction next. We have a subject. Okay, so we skip, then we get the next word. If it is a noun, Then we return all the list of the nouns. Okay. So I am currently on skip word. Okay. So I'll peek will check, right? If the word type, and then match will return the word or so. Okay, so since this is a reference, so it is doing uh, actual changes in the list, right? Right. Okay. Skip function to skip over the words we don't require, return the rest. To skip, yeah, to remove the words from the list that we don't require. Okay, skip. So we will take the word list and word type, right? So while peek equals, okay, so we are peeking and we are getting the word type, right? So we get the first word from the list, and then we are matching, so this will keep on popping the words, right? Right. Skip. Keep on updating the word list. If peak word list, skip. Okay. Match. It will return none, or else it will return the word. Okay, so while the we are peeking word list, it will return the type. Equals to word type, right? Word type. Okay, so you should write a word type, return word type. Expecting return the word, else return none. Okay. When we match it, peek. Okay. Word type, word list. All right. So effectively, what we are doing, we are popping from the list the word that we are expecting, and if that word is what are expecting, okay, if it has the type, so we remove it, right? Else we don't. So so it will only keep the words that does not match the word type. Not match the expected word type, right? Yeah, okay, that's a basic set of parsing functions, and with that we can actually parse just about any text we want. Our parser is very simple though, so the remaining functions are short. First, we can handle passing a verb. Alright, def parse verb. Okay, so it takes the word list and then we skip over the stop words. We can skip the stop words. Right, then we go, if we have a verb, then we return, okay, match, okay, we'll keep on returning the match, will return the first verb that it encounters. Okay, if at top we have a verb, then we return that word, which is a verb. Okay, then we have if peak word list equals verb then we match the word list with a verb. Okay. Else we can trace a parser error expected a verb next. Okay. So expected, else we can raise, okay, we have to raise it. Error expected a verb next. Okay, expected a verb next. Okay, we can skip any stop words, then peek ahead to make sure the next word is a verb. If it's not, then raise a parser error to say why. If it is a verb, then match it, which takes it off the list. A similar function handles sentence objects. Okay, so we parse objects. Retrieves the word, which is a verb. Again, I think these functions will be same. Again, from the word list, we will remove all stop words, then we peek ahead to check if the next word is an object, right, is a noun or a direction, is a noun or a direction, right? Okay. Yeah, I have to return this matched word. Return match. Hello. We can check if the word is a direction. Then we can return the word which is a direction, and else we can raise a parser error expected a noun or direction next. Okay, then we can raise a parser error. Right, we have that parser error. Okay, expected a noun or a direction. Next. Again, skip the words, peek ahead and decide if the sentence is correct based on what's there. In the in the parse object function, though we need to handle both noun and direction words as possible objects. Subjects are then similar again, but since we want to handle the implied player noun, we have to use peek. Okay, noun. Next is verb. Right, then we return noun as player. So we'll start with subject, right? We'll start, yeah, we'll first parse for the subject, then we parse for the verb, then we parse for the object. Right. Parse sentence, verb, run, direction, north. Player. Right. If we peek at the verb, we don't remove it, we imply it. Okay, got it. Right. Right, so we have parse subject. You can skip over the stop words. Then peek word list equals a noun, then we can return match the noun from the word list, and if the first word is a verb, then we imply that we are talking about the player. Okay, so we imply that we are talking about the player, so we will return, I think it should not be a list, it should just be a tuple, right? It is just a tuple, yeah. Else we will raise a parser error saying expected a verb next. Okay. Okay. So with all that out of the way and ready, our final parse sentence function is very simple. So we have a parse sentence and it will return a object, right? Def parse sentence. Take the word list. It finds out the subject. Then it will, then we want the verb. So we can parse the verb. And finally we can parse the object. Parse object, okay. Like this, we can return a new sentence object. So you pass in the subject, the verb, and the object. Right. Okay. To see how this works, you can play with it like this. Alright. Try to map sentences to correct pairing in a sentence. For example, how would you say the bear run south? Try to map. Okay. The stop bear. Okay. So we can try this. Alright. No, I think there was a function, but okay, that's not important. So you go from exercise 48, import parser. Then we can say parser dot, what is it? Parse sentence. Okay, so parser dot parse sentence, and we have to provide a tuple. So we go noun. Okay, I can just map that. Then we have another noun, which is a bear, and I have another tuple. What is the word? The bear runs south. The bear. And we have a verb, which is run. Then we have a noun. Maybe it is a direction really. South. Parser dot parse sentence. Parser has no attribute. Parse sentence. Have I? Oh right. Okay. My bad. Okay. We go again from exercise 48, import parser. Okay. Parser dot parse sentencer. Right, yeah. Okay, expected a verb next. So we have the bear run north. Okay. So it has expect a verb, subject, verb list. Okay. Line 66. If word list equals noun, return the word list. Okay. So it was a noun, the bear. Verb, run, direction, north. Okay. If it is a verb, we imply that we are talking about the player, so we return that. Okay. So what did I do wrong here? We have parse subject, right? And in parse subject, it raises a error, expected a verb next. I do have a verb next. This is a list. Direction south. Okay. Let's Let's start with something easy. Parser dot parse sentence. Uh, okay, so we will start with a verb, right? Run. Then we'll start with the direction south. Okay, it still throws an error. Word list. It says expected a verb next. Expected a verb next. Okay, we skip. Is my skip function working correctly? Oh, that's why we need the tests, right? Parser error. Okay. So I would want to import parser. Let's write a test def test skip is the first, right? Peak. Okay, so I'll test peak. Okay, so we can peak. It takes a word list and returns the word type. Okay, so x equals to peak, right? It returns a type. It returns the word type. Okay, so it will take a list. I will provide it direction. And south. Okay, so we assert that x equals direction. Right. Let's start with that. Okay, so it failed. Test peak. Name error. Yes, that is my bad. I forgot. Parser. Let's try it again. Okay, it's still failed. Assertion test peak. Assertion error. Direction. Assert. Assertion error. Assert x equals direction. Right. Test failed. Okay, so it is failing. Direction and south. So effectively we have word list, right? Word type equals word list of 0. Yeah, this is where it is wrong, because how is maybe I have implemented words, sorry, peak wrong, right? Word list word and return word of 0, and am I returning word of 0 or am I returning word? Yeah, okay, there we go. Word of 0. List of tuples, we return the type. Now this should work correct, right? Okay, so then test, I can also test the match, right? So we take a word list and we take what we are expecting. Okay. So it will remove whatever we are expecting. Okay. First of all, then maybe this is correct up to here. Maybe I think that was my only mistake. I wanna try again. Put parser. Wait. So x equals parser dot parse sentence. I wanna start with a simple sentence. Let's start with a verb, right? Run. Then we start with a okay, verb run, and then we give it a direction which is north. Okay. So okay, it is still failing. Okay. Expected a noun in parse. Okay, now it failed in parse this object. Right. Okay. So parse object. Am I returning? Yes, I'm returning. Does match return? It does return words. Match. Okay. Yeah, I should definitely write a test for match. Okay, so we make a list of tuples. Let's say verb run, then we say direction, and then we say let's go east. Right. Okay. So I want to let's say a equals to match. Okay, what does match effectively do? Returns the word if it matches the expected type. Okay, list pop. If the type is what we are expecting, then we return the word. Okay, so it will return the and it also okay, right? Yeah, that's correct. So we pass an x and then I am expecting a verb. Then we assert that uh, a dot 0 is a verb. Then b match x, and then we say if it is a direction, then assert b of 0 equals a direction, and then c equals to match if it is an empty, right? Then we should assert that c is of type none. Okay. There's something, yeah, okay. Match is not defined. That is my bad. I forget. Here you go, parser dot. Yeah, none type object is not subscriptable. Okay, so there we go. We have more errors. Word list. So we pop from the list, right? And it gives me an error at assert a of 0 that none type object, so it has effectively returned none, right? Okay. So it has returned none when it shouldn't have. So I was expecting verb and I should have got if words list, right? Okay. The indentations, if word list, I'll return none, return word is 0 equals equals, right? So something is not right here. Right. Okay. So we have a verb. I take two tuples in direction east, right? That is the way. That is the way to check it. We take a verb, parse, match. Okay, then I call on match. It should return the word. When it pops the whole tuple. Then we check if tuples, if expecting. I am expecting a verb, right? I am expecting a verb, and I have passed a verb. So it should match, but for some reason this is passing a none, right? This is returning a none type. Let's print word here. I go popped word. If word list, and then we'll also the word list. Okay, so the word list, yeah, and the popped word direction east. Huh. Oh, okay, so by default pops from the right, is it? Don't it pop the first word, right? Pop at 0th. Okay, so by default it pops the last one. Okay, bug pop removes the last element. We should specify the index we want to pop to override specify the to override this behavior, this behavior. All right, so there we go. Pop at 0, and then we can try PyTest, and so we can test skip. Right. How much time has passed? Alright. Skip again. What are the next steps here? What you should test? Pass a test. Okay. Confirms everything in this code. Put the test in pass a test similar to file. That includes check for an exception by using the assert traces from the nose documentation. Learn how to use this so you can write a test that is expected to fail, which is very important in testing. Which is very okay. So we are test. Alright, study drill. I'm going to change the pass methods and try to put them in a class rather than use them just as methods. Which design do you like better? Then we have a make the parser more error resistant so that you can avoid annoying users if they type words your Lex screen doesn't understand. Improve the grammar by handling more things like numbers. And then think about how you might use this sentence class in your game to do more fun things with the user's input. Okay, I can't seem to make assert traces work right. Make sure you're writing assert traces exception callable parameters, not writing exception callable parameters. Notice how the second form is calling the function and passing the parameter, which is wrong. Okay, your first website. Alright. Okay, so I think test test skip. Okay, I can use this. And let's say I will add a stop word, the. So we can go skip x comma stop words, because I believe that's how skip words. We need a type. Right. Then we assert that x should be equals to it should be equal to only this. Oh yeah, okay. Person dot skip. Yeah, okay. Assertion error. Stop the. Okay, test skip. Verb. Okay. Verb direction used. It should have removed skip. Okay. Skip. Okay, while the word list equals word type. Okay, so this should be at the front. Alright. My bad. This should be in the front. Alright, now it works fine. Maybe finally now I should be able to do that from exercise 48. Import parser. Then x equals to parser dot parse sentence. I can start the stop word. Hey, it should have, yeah, x. So x dot subject blah, x dot verb run, and x dot object obj, x dot object north. Huh, how come this is okay? Alright, so I can also have can also make this one work, right? The bear run south. Okay, run. We can make this south. Then we can add a stop the. Then I can add the noun bear. And no. Okay. All right. My bad. Where? Why? Why does it give me that error? Alright. No, this is okay. We have stop, comma, the, comma, noun, okay. Unterminated string literal. I stupid or something? Or am I stupid or something? Why does it say that I have? Okay, I think. Okay, yeah, okay, got it. So it was this guy. Subject bear. X dot verb run and X dot object south. Okay, great. Okay, so I am done with this first website. I think we will continue it the next time.